Hello there, good people, how's it going? My name is Marco, welcome to my channel. For today I have not one, but two mini projects, let's say. If you wanted to, know more, well then keep watching. FYI, all these projects come from an article online. I always leave the link in the description, so feel free to check it out. However, if you wanted to share some of your projects, or if you were interested and had any suggestion for new projects, I would be very, very happy to try and develop them on this channel. So feel free to send them in. Two mini projects because they are tiny but also very similar. Not much for what they do, but the way you implement it. For their implementation, you need to create basically a simple script that solves it all. It's very brief, but it's super effective. The first mini project in this case is Fibonacci. Oh yeah. Now, some of you might know it, but for those of you who don't know it, Fibonacci is extremely well known, especially among computer science students, and also for beginner programmers, because it should be the algorithm where you learn recursion, because it is very easy and quick to implement and understand. Fibonacci in itself is a numerical sequence. So it's a sequence of numbers, so it's a mathematical kind of argument. I can tell you that is strongly related to what is known as the golden ratio. Now, if you were interested in this topic, I will leave the link to the Wikipedia page in the description below, so feel free to check it out. It's a very good read, it's very compelling. Now, how does it work? As any numerical sequence, I need the rule that makes it. What makes the sequence? And in this case, it's very simple, very straightforward. Every number is the sum of the two numbers preceding it. So the first few numbers of the series are 1, 1, 2, 3, 5, 8, 13, 21. And as you can see, each number is basically the sum of the two numbers that comes before. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and so on. As I said, I'll implement the recursive version for this script, for this algorithm, and let's see how it's done. Okay, so what I have here is the recursive implementation of the Fibonacci sequence. Now, as you can see, it's quite clear why this can be used as, as the first tool to learn recursion, because it is very simple. After all, I just have two base cases, and I have two because I'm checking the two previous numbers. So there might be cases where I have 1 and where I have 0, and then I just return the function. This is where the recursion happens. So I just return the Fibonacci sequence for one number before what I input and two numbers before. So this should work. So let's check out what's the 10th number in the Fibonacci sequence. And it's 55, which is correct. Is it? Yes, it is. Trust me. Let's go a little bit further behind. 12. It's 144. Is it? It probably is. Let's push it. 30. And it's quite a huge number, but I guess it's correct. Alright, now the second mini project is leap it, which is to find whether an input year is either a leap year or not. Now, what is a leap year? Leap years are basically those years with one day more, 29th of February usually. For instance, 2020, funnily enough, was a leap year. There are some rules to this as well. In particular, year must be divisible by 4, which is, well, that's a given. But if it is divisible by 100, it needs to be divisible by 400 as well. This excludes quite a few. For example, 1900, which is divisible by 4 and by 100, is not divisible by 400. And as a matter of fact, 1900 wasn't a leap year. As you might have guessed, here I need a function that returns a Boolean value, so it basically returns either true if it is a leap year or false if it isn't. Okay, so this is the implementation for the leap year, and this function obviously returns a Boolean value, so true or false. And as you can see, I'm using the end operator here to just say both the condition must be true at the same time. So, as we said before, if the year is divisible by 100 and is divisible by 400, well then it's a leap year. Otherwise, if it's not divisible by 100 but it is divisible by 4, well then it's a leap year as well. All the other cases, they're not leap years. Now, you might wonder what this operator means, and this is called the modulo operator. Now, it is extremely useful in these cases because the modulo operator is basically a division, but instead of returning the result of that division, it returns the remainder. So if I had to divide 10 by 2, the result will be 5. But if I had to do 10 modulo 2, the return value will be 0 because there is no remainder there. In another case, for example, 9 modulo 2, I'd have a result of 5 because the result of the division is 4.5, so I have a remainder there. In all the other cases, I don't. Okay, so let's test it. 2020, we said it was a leap year. Let's see if it's true. Okay, it returns true. For 2020, it works. We also said that 1900, it wasn't a leap year. And this is the moment of truth, and it is false. So for these two cases, it works correctly. Okay, it works fine, but the code is, what can I say, is ugly. It's not very good to look at. It's not very good looking. I mean, I have the if statement, else if, and I have to return true twice. I mean, there's a lot of repetition. I'm not a big fan of this solution. How can I improve it? There is an inherent characteristic of comparative statements in Python and any other language as far as I know. The comparison itself returns a Boolean value without me asking for it. For example, if I check if a number is equal to 1, the comparison will return either true if it is or false if it isn't. Now I can use this to my advantage to make my code look a lot cleaner, because I can just write the correct check and just return what returns from there. I know that it's going to be a Boolean, which is exactly what I want. Pay attention, because I must write the correct check statement, because if I don't, well, I won't get the results I'm expecting. There are a few simple things to keep in mind when talking about Boolean logic, especially in terms of logical operators. I've used one before in the script, and that is the AND operator between two statements, and is very easy to understand. Both of the statement needs to be true at the same time for the entire comparison to be true. Now I want to add another operator, which is the OR operator. Now this operator, the logic is a bit more permissive, because you just need one of the two statements to be true for the full comparison to turn out true. So as you can see here, it might look difficult at the beginning, at first sight, but there are a few things going on here. Let's break it down. So first of all, I have these parentheses, and they allow me to give a hierarchical structure to the whole comparison, because I'm basically saying treat this as a whole block and this is another block. So I'm gonna basically compare two blocks which are either true or false. Now you might notice how one of these two blocks will always gonna be false, because in the case that the number is divisible by 100, well then this is going to be false. And since I have an AND statement inside of this block, just one false comparison will return a false block. But I don't care. Why? Because I have the OR operator. So I just need one of the two blocks to be true, and the whole statement would be true. Now, it is not very difficult. I just basically took this whole statement and put it inside here. So this will be evaluated exactly in the same way. And the same goes for this one, inside of this block. Now, as you can see, it is way more elegant and, in a way, more legible. I don't have to return true or return false. There is no repetition and anything. I'm just waiting for the return value which I remind you is a Boolean value. I'm just waiting for the return value of this whole comparison. And this is gonna be my result. Let's see if it's the same. So for 2020, should get true. And yes, it is. They both true. Let's say for 1900, it is supposed to be false. Let's see. And it is false. So as you can see, it works exactly in the same way, but I'd say that this is more elegant. It's more, I don't know, good looking, let's say. Well, I had fun and I really hope you had too. These two projects were very easy, but very fun indeed. So thank you very much for watching. And again, if you had any project, if you wanted some help with anything, or if you had any suggestion, please feel free to comment down below. I'd be happy to implement them in my videos. If you enjoyed this video, leave a like so that more people can see it. And as always, don't forget to subscribe. I would really, really appreciate it. I'll see you in the next video. Stay tuned for more. Bye bye.